Hello everyone, thanks for joining us as we explore the use of the 5E instructional model in planning science lessons. I'm Francine Taylor Campbell, Education Officer for Chemistry. So, what are we expecting in our 5E's lesson? We're looking for lessons that are consistent with the NSC philosophy of student-centered learning. What does that mean? These lessons are to be filled with activities that are varied, certainly activities that lend themselves to real-world applications, which of course will make the learning relevant. Methods that are used should be learner-centered. So we're looking for discovery methods such as inquiry-based, problem-based, and project-based learning methods. And of course, all of these can be used with the STEM integrated approach. We also want lessons that see our students working together. So they must be group-based. They must cater to students at different levels. And so we're expecting to see the use of differentiated instruction. And where possible, lessons should try to integrate other subject areas. And when all is said and done, we will be able to achieve the 4 C's: communication, critical thinking, creativity, and collaboration. All right, so for this lesson is targeting grade 8, and we're looking at water purification. So there are some targets that we would have to ensure that are achieved based on the requirements of the NSC. So for this particular lesson, we're looking at applying scientific knowledge and processes to real-world problems. We're expecting to have students demonstrate positive interpersonal skills as well as an understanding of the processes involved in water purification. Other targets are mentioned in our benchmarks, as we'll see, and these cater to the development of competencies. So students are to demonstrate concern for their environment, and as it relates to this particular lesson, to be able to use the engineering design process to come up with different design solutions. Okay, now let us look at the key objectives for this lesson. So as you can see, our objectives should cater for different domains. So we have objectives catering to the cognitive domain, where students will be able to assess the impact of activities on water quality, and to also create a water purification device. The objectives will also cater to the affective domain and the psychomotor domain, as you can see listed. So they should be able to show responsibility towards the use of resources in the environment, work together as a team through hands-on activities, and of course, use some of the same apparatus as shown on this table. And throughout this lesson, we're catering to the development of skills, not just the 4 C's, but as it relates to science process skills, to be able to manipulate equipment, to be able to plan and design, analyze, evaluate, and solve problems. And we'll also be using some key vocabulary as it relates to water purification. All right, so let's get to it. Look at this picture and tell me, what are your thoughts? What comes to mind when you see this particular image? Do you think that the world needs water? That water is scarce? Or is it that there needs to be water to be available for different households? Let's look at this other picture. What are your thoughts? Seems as if the fish is struggling to breathe, right? What could be happening to the water to cause this? Right? It's possible that the water is being polluted, and so the fish has to be using some alternate means of getting water, or pure water, all right? So this is suggesting that there is some problems with our water supply. All right, let's look at the last image. What's happening in that particular image? Well, yes, somebody's fishing, but what's happening? What are they catching? Are they catching fish? They're catching garbage, yes. So what does that suggest to us? Again, our water sources are being polluted. All right, now we can look at scenarios in areas all over the world that show real issues that persons are experiencing with their water supply. Let's go. So here we have some pictures. You can look a bit closely at these pictures. Certain areas of the world, yes. There are some issues shown here in these pictures. What could we pick up from this? Is this water safe? Would you play in this water? What are the issues shown? Certainly the water is polluted. There is solid waste pollution of these water sources, right? And it's possible that in these areas, these children have no other source. And so they find themselves in these areas playing, probably searching for food, who knows, right? But certainly this is a real issue. And so what would be your solution for this particular issue? What about these pictures? What are the issues shown here? Okay, so here we have a different section of the world, but it seems as if there is an issue with supply of water. So it's not just that the water is polluted, but it may be severe drought. Something is happening why they're not able to access fresh water. So what would be your solution for these issues? So as you can see, these are some real issues that persons are experiencing. There may be even examples here in Jamaica where persons have issues with their water sources, right? Those sources are polluted. So how can we fix this problem? What is your solution? What are the possible purification methods that could be used to supply water to these persons? What could you do? All right, let's explore. Okay, so based on the issues shown, we can see that we would need to explore different water purification methods, right? What are some of the possible methods that we could look at? Certainly, based on what was shown, we may need to consider water filters. But of course, if we're in certain parts of the world where they may not have access to, certain apparatus, then we'll have to consider making our filters from everyday materials. So that's one. What other methods could we target? Certainly, based on the fact that in these areas, as shown, there's a possibility of diseases, waterborne diseases, we may need to consider disinfecting our water. How can we disinfect our water? A very common method is the use of chlorination. That's one. Another method that we can look at is the solar disinfection of drinking water, as shown in your pictures. Now, looking at that method, it really requires you to put that polluted water into the sun, yes, for a certain number of hours, and then voila, you can drink it. But would you drink it? Doesn't look so hygienic, does it? But this process is actually part of the water treatment process that occurs in our water treatment plants, because exposing the water to the sun will help to kill some of the harmful bacteria present in it. So yes, this is a possible disinfection method. But of course, for us to actually drink that water, we may want to add chlorine to be safe. All right, another method is the use of the water still. So let's look at that picture. What's happening there? So in the water still, we are actually allowing the water to evaporate and to condense on the insides of that glass covering, and then that water that has condensed is now collected in a bottle, which would represent our water still. This is actually a very important method, and it is based on the whole process of distilling water, all right? So it is also a method that we can use. Now, of course, as students go through and explore and research these methods, we can point them to the use of the internet to get some more information on these methods, to get some more details, right? You can point them to the use of their textbooks where they can find information on these different purification methods. Because the whole aim of this particular activity is for them to research to get information on these different purification methods. Now, once students have done this, then they are able now to present what they have discovered, what they have learned in a number of different ways. And as you can see, we're using a think-tac-toe. What's a think-tac-toe? A think-tac-toe is basically a use of differentiated tasks. Remember, we're catering for students at different levels, students who have different learning preferences, students who may have a different way of expressing their understanding of the concept. And so using this think-tac-toe is catering to the use of differentiated instruction. Students will express how they understand the material in different ways. As shown, they could create an advertising campaign about the effects of polluted water, act out a skit to show why you must purify your water before drinking, write lyrics to a song, write a letter, draw pictures, and write sentences about how the water pollution is caused by different activities, and so on, as you can see there. So here is an example of how we can cater to our students at different levels, yes, with different interests, different learning styles, okay, and so each student can demonstrate what they understand. All right, now let's look further at the picture, one of these pictures. It would have been shown earlier, right? And we're looking a little bit more in depth, right? So in this particular picture, we mentioned that it's possible that this area is suffering from drought, right? There is little access to fresh water. And so families, households would have to come to this particular area to get water. So this is a challenge. And this challenge is present in certain areas of the world. So here we are looking at real-world applications of this particular problem. All right, so let's look at the challenge that we have. So in a part of Eastern Sudan, persons living in these communities have this particular challenge. There's little rainfall, the water resources are few, farmers need to use them, households need to use those same resources, right? And so water supply is short. And of course, where water does exist, in some cases, these points are badly damaged. So the water that they have available would have to be used for drinking and cooking and so on. So what is left now for them to use for washing and cleaning? How would you, using this particular scenario, provide water for this particular area, right? That is good enough for washing and cleaning, right? And for use in the household. Let's see. So you're in this particular area. These are the resources that you have. Okay, you have plastic bags, coconut husk, coconut shell. That's what you can find around, right? Metal pipes, plastic bottles, and we have some samples of them here. Stones, pebbles, cloth, string, glass, paper, right? That's what you have around you. And we're saying that in this particular challenge, we want you to come up with solutions as to how we could make water available for washing and cleaning. So that's what we're using this water for, using the resources listed. What are your thoughts? Could we use plastic bottles and sand and dirt and gravel to purify water? What about coconut husk? What purpose would they serve? Think about it. All right, so this is a possible solution. You can come up with your own solution, but this is a possible solution. So in this solution, as shown, we're going to be using our plastic bottles, right, to make our water filtration device. Who knew that this is possible? All right, So this particular activity is available in detail on a video, the link for which will be given, right? But for now, we will demonstrate it so that you can see what we're actually doing. Okay, so in this activity, we're looking at designing, okay, our water filtration device using some of the same materials that were mentioned earlier. So this is what we have. We have plastic bottles, right? We have our cotton wool. We have gravel and sand. And we have charcoal, activated charcoal that's present in this container here. It's a black powdery substance. All right? And of course, we have water or filter funnel, right? Measuring cylinder and some samples of dirt or filter paper or a pair of scissors and plastic spoon. So we're going to use these materials. Certainly, apart from our activated charcoal, everything else can be found in our immediate environs, right? Activated charcoal can be purchased at the pharmacy. So I know we have certain soaps now that have charcoal in it. All right? So you can always get that at the pharmacy. Okay, so how does this thing work? All right, so we get our plastic bottle and we are cutting our bottles, all right? Just to get the top section removed. All right, and we, of course, we're adding our first layer. If you look at the diagram, we'll be placing our cotton wool at the bottom. If you don't have cotton wool, you could always cover the mouth of the bottle with cloth, yes, and you could wind some elastic bands around it. You can be creative with this, all right? So I'm going to put some cotton wool. I'm sure we can find some cotton wool somewhere. And we are packing it in. So we just pack it into the bottom, all right? Yes, all right? And that is our cotton wool, which would represent our first layer. Great. All right, so what do we add next? So we're adding materials based on differences in particle size, all right? So our activated charcoal, very fine powder, is what we will be adding next. So essentially, we would just pour it on top, ensure that we cover, okay, very fine, cover our cotton wool, all right? Great. What next? What do we add next? Well, we'd need to add some sand. So we're adding our fine sand. So again, we're increasing in particle size, adding our fine sand. Fine, so we would have added our fine sand, right? So what do you think we should add next? So this is our fine sand, okay? We have poured it on top of our activated charcoal, right? And now we want to add another layer. What should we add next? Well, certainly if we're increasing in particle size, we can consider adding some coarse sand. All right, so I'm just going to transfer some coarse sand from this device that we made before, right? So we'll add our coarse sand on top of our fine sand, all right? Just enough to create a layer, right? Good. And then after that, what next? Well, certainly we can now add our gravel. And here we're adding our gravel. You can get your gravel anywhere where we know we can find these small stones, gravel, pebbles, same thing, right? And we're adding it on top. So if you look carefully, our device is set up with our cotton wool, charcoal, fine sand, coarse sand, and then our gravel on top. We can now remove the cover and set up our device. But to make it more interesting, we could compare this homemade, yes, water filtration device with our usual filtration apparatus that uses our filter funnel and filter paper. So we're basically comparing these two devices to see which one would be more effective at purifying our water. Of course, if it is that we're in an area where there's little access to water, they may not have filter paper and filter funnel. So we're just comparing to see how this works. So we place our filter, okay, just before we do that, we want to flute our filter paper to ensure that the process works pretty quickly, right? And fluting, you're just folding it multiple times to ensure that you have a larger surface area for filtration. All right, this paper is not working with me. All right, so here we go. So we'd place our filter paper in our funnel, all right? And for this particular demonstration, we'll just put it on top here. So now all we need is our polluted water. So let us simulate some polluted water. All right, so we're going to pour some dirt. Brought some dirt with me. Yes. To create our polluted water here. All right. And we're adding water, mixing some water into this. And we're going to add this to our two filtration devices, right? So we have our homemade filtration device that we could use, and we have our established filtration device that uses our filter paper and our filter funnel. All right, so let's go. Let's pour. Just stir it up a bit. What do you think will happen when I pour this onto our filtration device? All right. While we wait, do you think the filter funnel or our crude device will be better? So as you can see, our filter funnel happens to be very fast. So it has already started to filter out the particles from the water. All right? But our filtration device using our plastic bottle has not started filtering yet. But have no fear. We expect that it will start sometime soon. Let us move these so you can see it clearly. So our filter, yes. Okay, so we have our water being filtered here using our filter funnel. All right, working quite nicely. As mentioned, because we have fluted the filter paper, it allows that process to be very efficient. All right, and let's see if we can see something happening here for our plastic bottle filtration system. All right, so we have some activity starting. Look here. All right, let me see if we could actually show you what's happening here. So as you can see, and look at the water. Did you expect it to look so clean? Something so simple, and we're getting clean looking water, but I bet you still wouldn't drink it, right? So we are comparing then our two systems. So if we could create a filtration device using simple materials compared to this one, we can see that this process is quite efficient, yes. We're getting clean water. Why is it? And we could probably compare the color. May not be able to see it here, but this is slightly colored, whereas the water in this particular, from this particular device seems a bit clearer. What do you think accounts for that? Why would this system be much clearer than this system? Well, certainly the use of the charcoal is what accounts for the water becoming so clear. All right, so certainly then we are exposing students to real-world situations. They are actually applying the engineering design process to solve real problems, right? So this is an example of STEM integration, okay? And they are going deeper into the subject matter to see how it is that purifying our water will apply to real-world situations. Fine. Now, when students have done this, they can then be asked to present their devices, right? To explain how it works, to explain the water purification method that is being used and how it is that it would work in this particular situation. All right, students can be graded using our filtration rubric that will be shown. They will be graded for their invention, their explanation, their use of time, and of course, how well the group would have collaborated to make this activity possible. Okay. Now, throughout this lesson, we want students to be conscious of how their actions will affect their water resources. And so we want to stress their responsibility to conserve water resources around them. And to get students to think more on this, we can have them reflect on how they use the water resources that's available to them. So at home, how do they use the water? Do they ensure that all taps are turned off? Do they ensure that where possible they can reuse water, right? And have students think about what they can do to ensure that our water resources are conserved. And of course, we want to get an indication of what they have learned, what they don't understand, so that these areas can be addressed in the next lesson. So we can have students complete that exit slip to say what they have learned, what they need to know more about, and as the teacher, you can address those issues based on the responses given. So, going through this particular activity, how was the 5E model utilized in this lesson? Where were the 5Es shown? So certainly, yes, we're looking at how to get students interested. How did we get the students interested in this particular lesson? What did we do? We would have looked at a series of pictures and graphics at the beginning of this lesson, and students were expected to examine those pictures, look at the issues presented, come up with their ideas, what are the real problems being experienced, and possible solutions to the problems identified. Next, we would want our students to get some more information, to go a bit deeper, to construct new knowledge. And so they were expected to know, research, explore different water purification methods that are suitable for these particular households in these developing countries. So we're not looking for the elaborate water filtration system that some households may have. We're looking for methods suitable for these households in these areas of the world where issues are real. Right? And so some of the methods that would have been explored included disinfection, use of the water still, chlorination, filtration, of course, and solar disinfection, to name a few. All right. Now, students were now expected, after researching those methods, to present what they found out. And they were to present it using different choices on the think-tac-toe activity. So based on what they understood, they could make their presentation. They could have done a skit, create a poem, write some sentences, come up with different ways of presenting their understanding of what causes our water to become polluted and how they can be purified. And of course, students would be given the opportunity to assess the work of their other peers. All right? And that's important because we are advocating for formative assessment. So as we go throughout the lesson, we want to see how it is that assessment is being carried out. Now, once students have demonstrated that initial understanding, we want to take them deeper. How can I get my students to apply this knowledge to other situations, to real-world situations? And so here they were presented with a challenge of how to plan and design a low-budget method of purifying water in a country that has little access to water. And so students would have gone through this process of coming up with their water filtration device, of presenting their device to the other group members, and to have those devices assessed using a teacher-prepared rubric that was shown earlier. And finally, as mentioned, we would have been evaluating our students throughout. So from the start, as they were looking at the images, right, as they were discussing different water purification methods, you would be assessing their knowledge. You are giving them an opportunity to present their findings, yes, and that also requires some assessment using the rubric. And as they think about how they use their water resources, if they're using it properly, if they're conserving at home, what ways can they really use to conserve water, we are employing self-evaluation, self-assessment to see how they use their water resources. And finally, they would have been asked to complete an exit slip to check for their understanding and for there to be adjustments to be made for future lessons. Okay, so you have seen a demonstration of a 5E lesson. Now, when we started, we mentioned some things that we're expecting from a 5E's lesson. So, did this lesson live up to those expectations? Did it cater for group-based activities? Did it cater for the use of hands-on activities, activities that are related to real-world situations? Did it make use of inquiry, problem-based or project-based learning, and infuse that into the STEM approach? Yes. Did it cater to the development of skills and attitudes? Right? Did it cater for the achievement of the 4 C's? You can make your assessment, but certainly we're looking for lessons that cater to these expectations. So let's hope that you are able to follow through and you will be demonstrating these student-centered lessons to your students. Thanks for joining.